All right. So that's that. And you guys want the microphone turned on. Do that. Okay, but let me just, well, I guess I should turn this on first before I answer the question. First thing first, right? C. Okay. Gain is all the way down. C. Power switch. 0. Okay. The gain is too high, so I have to C. Is that good? Okay. All right. So, so the question, to answer your question, the question is, how are bytes in a text file, or how are characters, digits, and punctuations represented in a file? That's basically your question.
Well, and when you're doing equations, is it always going to be ASCII code type, subtraction, division, any type of math?
Whenever you subtract, you're looking at the value represented by the bit pattern. That's how you do the actual calculation, right?
So is it going to be in ASCII code form? Always?
It's whatever you read from the file. So if we are using epsidic, then it will be in the epsidic representation.
If you're using what?
Epsidic. We talked about epsidic. It's a very epsidic. It is a very old standard of character encoding.
Well, how do we know which one for math? So I know it's being subtracted by a hexadecimal, but we're translating that hexadecimal number into an ASCII code character number.
No. There's no translating. It is really just a different way of looking at the same thing.
Well, there's got to be a translation because they all mean different numbers. They all have different numbers.
Okay, so let's do a hex dump. Oops. Dash C id.txt. Okay, so this is the actual hex dump, which means on the left hand side, 3.1 is corresponding to the character 1, 3.2 is corresponding to the character 2, and so on. Okay, that's the content of this file that I just created, which is 1, 2, 3, 4, 5, 7, and then the line feed character. Okay, so what are we seeing here? Okay, first of all, let's do an ls-l id.txt. The file has exactly 8 bytes or 8 characters. So those 8 characters are representing 1, 2, 3, 4, 5, 6, 7, and the line feed character. But what exactly are those bytes? Okay, the first byte is 3.1 in hexadecimal. The second byte is 3.2 in hexadecimal, and then the last byte is 0A in hexadecimal. What are those things? Well, can someone remind me what is a byte? B-Y-T-E.
8 bits.
8 bits. Okay, and 1 bit is a binary digit, which means it is a 0 or 1. Is that okay? So that means this is represented using 8 bits. This is represented using 8 bits, and so on. But how come we are seeing 3.1, which obviously cannot be a binary number? Because 3.1 is in what base? It's in hexadecimal, which means it is in base 16, right? And we use base 16 because we don't like to write a whole lot of digits. Because otherwise, I will have to write 0011 0101. Excuse me, 0001 as the last 4 digits. So it's really cumbersome, and that's why we use hexadecimal digits.
In the equation, though, we're not using hexadecimal digits for the subtraction. We're using ASCII code characters.
But that's the act. Go ahead.
What's happening is it's all in binary from the start. The reason it's doing it in ASCII is when we scan it in, we scanned it as a character type. And so in that case, it's taking it as a literal character, and then when we do a mathematic operation, it's sort of implicitly casting it as the ASCII code to make a numeric value.
Okay, so we're only doing ASCII code math with characters being represented in ASCII code because we're using scanf in character form?
Yeah, the scanf is the same point, it's just the fact that it's a character in the operation.
Okay.
Okay. All right. So getting back to this example here, so the answer to this particular, if your student ID is in fact 1, 2, 3, 4, 5, 6, 7, then we'll have basically 1 plus 7, and then 3 plus 5, and add those 4 numbers, and that will be the answer, which is 16 in this case. So sum would be 16 because it's adding up the value of all the odd digits. Is that okay for the first question? Yep.
How come it says, is the text file for the first question our student ID written out in text form?
Just to be sure that we understand it is a text file, that's all.
So it's not supposed to be written in text form.
Well, because if I don't specify that, okay, someone can accidentally think, oh, we are representing, 1 as 000001 as a byte. We're representing 2 as 00000010 as a byte. So by emphasizing that we are using, we are containing your student ID in text, I'm just emphasizing that we are using ASCII code to encode the individual digits.
So just think of it as...
I know, because I went up and asked him, and because I thought that said, especially with a comma, you contain your student ID in text, meaning like written out in one, like in alphabet letters, and then the 7 digits, and then the ASCII code 10 character. So it was a lack of clarification for me.
Okay. Because in the practice test, it was exactly the same phrasing. It was just processed differently in the practice test. Okay, here comes question number 2, which is a little bit more complicated, but not too bad. I really like this one too, actually. It is recursive, okay, so I don't even bother to ask you whether it is recursive or not. In the following space, indicate how local variable x of main, which is this guy here, and local variable r of f, which is this guy here, are getting updated. Okay, so every single time if x of main or r of f is updated, you have to tell me it is updated to what value. Okay, in the ordering is important, so don't get it out of order. This is just an illustration. If you think that r is updated to 2, and then r is updated to 3, and then x is updated to 5, then you want to show me a list of assignments like this. So I want you to indicate your answer here, which basically means you have to trace or follow the execution of the subroutine. It is recursive, and basically give me the answer accordingly. We have already talked about how to trace a subroutine using a spreadsheet, so you can use that approach. Okay, it's going to be helpful, but it's going to take time as well if you want to use the entire full format. So what you want to do, or what I can do, is to talk about the structure of the code. So instead of having to really trace it like step by step, you can just kind of go, okay, this is the first call, this is the second call, this is the third call, and you can simplify the trace in order to get to the answer. And for that, I'm going to use a mouse pad, which is just like a notepad, different name, same thing, and go ahead and try to figure out what is going on here. All right. So what is the first? Okay, so what we do need to keep track of are the invocations. So we first get into main. Okay, main doesn't really do anything, and then we have x equals to something. Okay, we don't know what that something is yet. Okay, so I cannot document x equals to something at this point because we are not actually carrying out the assignment operation. We are trying to call f at this point, which means the next thing we do is to call f. The first invocation of f is spelled out. The first parameter is the rightmost 3 digits of your student ID. Using the test ID that I have been using, it's 1, 2, 3, 4, 5, 6, 7. So 5, 6, 7 is the first parameter. And then 512 is the second parameter because it is spelled out here. Now that we know, it is a function call to f with 5, 6, 7 as x and 512 as y, we now continue execution in the subroutine itself. The first part of the subroutine compares y to 1 and asks is y greater than or equal to 1. 512 is quite clearly greater than or equal to 1, so we have to go into the conditional statement here, this part here. And then the second question is to ask whether x is greater than or equal to y, which is also true in this case. So now we have r equals to 1 plus the f of 567 minus 512. And this is where when the calculator can come in handy for those of us who do not like to do arithmetic calculation. But even I can do this one. I think it is 55. Okay, that's the first parameter. Y divided by 2 is 512 divided by 2 is 256, so that becomes the second call. Okay, but I cannot write down the update of R just yet because it is not ready to be updated yet. Okay, in order to figure out how this R, local variable R, is going to be updated, I have to figure out what is the return value of the second invocation of f first. So that means that brings us to the second invocation of f with 55, 256 as parameters. When we get into the second invocation of f, we start from the very beginning again. Y in this case is 256, which is greater than or equal to 1. So we ask the second question of whether y is greater than, x is greater than or equal to y. That is not true this time, because x is 55 and y is 256. So we go to the else statement in this case. So I say, okay, this time when we update r, it's going to be just f and x is 55 all by itself, but y needs to be divided by 2, so it becomes 128. Are there any questions at this point about how I'm tracking the execution of this code? Now this is definitely a very much simplified way of doing things compared to the full spreadsheet notation. But since in an exam you may not have enough time to do a full spreadsheet, I'm going to use a simplified version that can convey the same ideas. Are there any questions about the first and the second invocation? We are ready for the third one at this point. Yeah? Okay. So in the third invocation, which means f of 55 as parameter x, 128 as parameter y, we go through the same exercise. Okay? Is y greater than or equal to 1? 128 is greater than or equal to 1, so that is true. The second question is x greater than or equal to y? The answer is no. So we get to this part here. So now we say r equals to f of 55, which is just x itself, but y has to be divided by 2 before we pass it on to the next invocation. 128 divided by 2 is 64. And now we move on to the fourth invocation, 55 and 64. Basically the same thing happens. We have to call it again, r equals to f of 55 and 32 this time. And then we get to the 1, 2, 3, 4. This is the fifth invocation. So in the fifth invocation, we go for the then case, because in this case 55, which is x, is greater than or equal to y, which is 32. So this time f of 55, 32, when we get to the conditional statement, we'll say r equals to 1 plus f of 55 minus 32, which is 23, and then the other one has to be divided by 2, which is 16. So now we go for our sixth invocation, 23 and 16, and we keep asking those questions. We end up with r equals to 1 plus f of 23 minus 16 is 7, and then we have a 16 here. 8. We have to keep dividing parameter y by 2 with each invocation. So now we have f of 7, 8. Do you guys notice what it is trying to do?
What's that?
Do you guys notice what it is trying to do?
It's trying to get the x value to 0.
It's trying to get the both of them, okay? But when we stop the recursion, it is not because x is 0. It's because y becomes 0.
Oh yeah.
Because the conditional statement has it only compares y to a particular value 1. So if y becomes 0, then it gets to here, and we stop the recursion. But along the way, I think this will become clear.
What happened for me was once I got to 1 and I divided 1 by 2, I considered that 0 because of the way the computer likes to do math in terms of like modulus.
Okay.
It likes to do remainders instead of putting like 0.5 or something, because that's lower than 1, so that wouldn't meet the condition.
Okay.
Would that be correct?
You can't get y to equal 1 because it's even.
Why not?
Because it's even. Y is always even when you divide it by 2. How can you get
What is 2
1?
divided by 2?
0.
What is 2 divided by 2?
Oh no.
Divided by 2 is 1.
I don't know why. I don't know why I even thought that. It's so stupid.
Modulus.
Yeah, I was thinking modulus.
Computer science and math start arguing with each other.
Yeah.
So you're trying to go the other way.
did modulus. All kinds of wrong. That's what I got the right answer.
Okay, I'm just going to finish this. I know this looks kind of boring. Now, how can you tell whether this is actually what the program is going to do or not? Exactly. This program does compile and it does run in GDB. You can stop at every single level.
I did that right.
And if you run it all the way down to the deepest level and you do a backtrace, it will show you all the invocations. So you can actually visualize and see all the parameters.
So am I right?
Hmm?
Am I right?
About
When you get to 1, once you divide it 1 by 2, you'll get 0.5, which means that it exits the loop?
yes.
Okay.
Because I specifically use greater than or equal to 1 here because I know somebody is going to say, what if it's 0.5? That is not possible.
Yeah.
Can y be 0.5?
No, it can't because it's a decimal.
Because it's an integer.
Yeah.
Exactly. So, but I just want to make sure people do not get into that problem. So I use greater than or equal to 1 because even if you think it's 0.5, it will still terminate.
Yeah, you just sat there kind of silent. I was like, am I right or not?
Well, because I'm trying to finish this trace here. Okay, so 1 versus 1, it will go through one more time. So this time it will become r equals 1 plus, the first one is 0, the second one is 0 as well. So both parameters are now zeros. And then after this, it will return, okay? Okay, so now we have f of 0, 0. F of 0, 0 is going to go where?
It's going to go to the else statement, which makes r equal 0.
Yep,
R
exactly.
equals 0 at the end.
Yep,
And
there you go.
So you put each invocation of x and then r equals 0 at the end?
Say it again?
You put each invocation of x, correct?
Each invocation of,
Like whatever, whatever x would equal from f, like even though it didn't return.
okay, so, okay.
I forget what you said, the way you worded the question. But,
Okay.
Yeah, basically r equals 0 at the end.
Oh, so r equals 0 is important because this is where we stop the recursion, okay? But when we stop the recursion, what do we do? What do we use this r for? This r has a definite value now, but what do we use it for? R is used for the return statement at the end, which means it is going to replace the invocation itself with the value of 0 in this case. But which invocation are we talking about? It's f of 0, 0. In other words, this becomes just 1 plus 0, which is just 1. Okay? But this belongs to the previous invocation. So that means we have r equals 1 at this point. Okay, because this r equals to 0 is happening because of this statement here, right?
Yeah.
And what do we use that r for?
We use r to return.
And when we return, where are we returning back to?
We're returning back to main.
No. This is recursion.
We're returning back to the previous recursion.
We're going back to the previous invocation, right? So when we return, we're returning back to here. The only reason why we have r equal to 0 is because we are trying to figure out what is f of 0, 0. But why we are figuring this out is because we have 1 plus f of 0, 0. So now we know what is f of 0, 0. We plug that 0 in place of f of 0, 0. Finish up the addition so that we can change this r. Is that making any sense?
Yeah, I was
Yes,
confused
yeah.
with the one. And
Sorry?
I was confused the part when you say R1 at the end, so I couldn't figure out to connect with the R0 and then 1. No, I'm saying I was confused how to go back again to the R equals 1 plus F00. So that's where I lost the connection of the whole.
Well, that's why we talked about the tracing, right? You know, remember we talked about the tracing of a subroutine that returns a value?
That was a lot. That's why I couldn't understand. Okay, where am I now? So it was just.
But you have to do it. Even though it's long and tedious, you have to do it. Unless you can analyze what this code is really trying to do and do it analytically. There are two ways to solve problems in this class. one way is to trace it, okay? So one way is to basically to say, okay, I know the basic stuff. I know what this statement is going to do. I know what function calls will do. I know what a return statement will do. So what I'm going to do is I will follow the instructions as if I am the computer running this program. That's one way to answer questions in this class. The second way to answer questions in this class is to analyze the code structurally, figure out the meaning of the code, and go, oh, now that I understand what this code is doing, I can figure this out by hand without tracing it. Okay? So those are the two ways to answer questions in this class. Unfortunately, I do not think there's a third way to answer questions, other than throwing a dice and say, I think R is going to be this, that, and whatnot. Okay? But you have to choose one of the two ways to answer questions. Okay? So one way is tedious, but it's kind of easier in a way because you don't have to analyze the code. The other way is shorter if you want to analyze the structure of the code. Is that okay? Sort of? Maybe? Okay. So if we go through this, okay, if we just kind of go, okay, I forgot the indentation here. So got to get the indentations right. So this r equals to 1 is going to replace this r equals to 1. And that goes all the way back to replace this r to 1 plus 1, which is 2. And that 2 is going to go back to this r equals 2. And that r equals 2 goes back to here, which makes this r equals to 3 because it's 1 plus 2. So this r is 3. And that goes back to this r, which is just 3 because it's not 1 plus, which goes back to this one, which is a 1 plus. So this r is 1 plus 3, which is 4. That goes back to the previous one, which also has a 1 plus. So that becomes r is 5. And then the other ones do not have a 1 plus except for the last one. So we have r equals 5, r equals 5, r equals 5. And then the last one, I think, is r equals 6. Let me see if we, nope, we're missing one more. Okay, I think that the indentation is correct about this one. Yep. So eventually the last r is going to be returned here, so the x gets that particular r, which is also 6. So the correct answer, assuming your student ID is 567, would be r equals to 0, r equals 1, r equals 1, r equals 2, r equals 2, r equals 3, equals 3, equals 4, equals 5, and then 5 all the way except for the last one, r equals 6, and then x equals 6. Okay, but what is it really doing? What is this 6 really, indicating?
What did you say the student ID was? What was the student ID again?
5, 6, 7 are the last 3 digits.
Oh, this is one.
So if you look at 5, 6, 7, 567, what do you think comes out as 6?
The middle digit.
The number of bits there are ones.
Oh.
Yep. It's a base conversion program. It is converting the number into binary. But every time I encounter a 1, I count, I keep count of it.
Now it's making some sense.
So is there a faster way that we could do this to test our answers? Just
To-
like using an online calculator or something?
Well, I think there are some calculators that can do base conversion. Any type of calculators that can do base conversion can do this. Okay, so we are looking at 567 as a base 2 number. Okay, so how do you do a base 2 conversion from base 10 to base 2?
You just divide, keep on dividing.
Keep on dividing, but you have to track something. Every time you divide, what do you track?
The remainder.
The remainder, very good. Okay, so we basically say this is 2 times 256. Yep. Okay, so 567 divided by 2 is
Remainder 1.
283 with a remainder of 1, right? 283 divided by 2 is 141 with a remainder of 1. 141 divided by 2 is 70 with a remainder of 1, right?
Yep.
70 divided by 2 is 35 with a remainder of 0. 35 divided by 2 is 17 with a remainder of 1. 17 divided by 2 is 8 with a remainder of 1. 8 divided by 2 is 4 with a remainder of 0. 4 divided by 2 is 2 with a remainder of 0. 2 divided by 2 is 1 with a remainder of 0. And if you want to, you can keep going, because you can always say, what is 1 divided by 2? It is 0 with a remainder of 1. And you can keep going too, because what is 0 divided by 2? It is 0 with a remainder of 0. What is 0 divided by 2? Is 0 with a remainder of 0. So you can keep going like this, and it's not going to change the number of ones. So we counted 1, 2, 3, 4, 5, 6 ones. I'm actually kind of surprised that I got this trace right, because it's tedious. Now, what about the grading? Okay, how are you going to be graded on this one? I'm looking for indication that you understand recursion. Okay, so by looking at how the R values are getting updated and how many times it is updated, I can at least tell whether you understand some parts of recursion or not. Okay, whether you understand the math part of the trace or not, and so on. So I'm going to use the updates of R and X as an indication of how well you understand recursion. Yep.
Because I'm dense, I don't understand what those remainder ones are. Are those where it looks like in binary or something? I don't understand.
Yes, as a binary number, 5, 6, 7 can be seen as 1, 0, 0, 0, 1, 1, 0, 1, 1, 1.
That 5, 6, 7 is 1, 1, 1, 0, 1, 1, 0, 0, 0, 1.
No, the other way around.
Oh.
We actually talked about this in this class too. Base conversion is one of the early topics that we talked about.
Okay.
Okay, I have $567. You can only have currency, denominations of 1, 2, 4, 8, 16, and so on. So what kind of bills are you going to give me to come up with the same amount of $567? It's asking the same question. Is that okay?
Okay.
Okay. All right, so that is number 2. Question number 3. Question number 3 is not recursive, but it does have the use of a pointer. So if you look at function f, does it remind you of some operator that we have talked about in this class? No. Array is completely out of this particular exam. I said that there will be no arrays.
Is it trying to act like a swap?
No, it's not a swap.
Or
It is adding 1 to something. So the question is, this is our mystery line. What is it doing?
adding 1 to the address of x.
No, it's adding 1 to what x is pointing to, what px is pointing to. Okay, so px itself is an address. But I'm not adding 1 to the address. I'm adding 1 to whatever is at that address. Okay? But then what do I return? Function f actually returns a value. What am I returning? I'm returning the value of whatever is at px before the increment. Does it remind you of one of the operators that we have talked about?
No. Very no.
Try post increment. X++, because X++ has 2 things to do. The first thing it does is to say, oh, what is the current value of x? Let me remember that. And then it will add 1 to the value of x. But as an expression, what is the value of x++? It's the value of x before the increment. This does exactly the same thing. Okay? So that means if I have my student ID as 1, 2, 3, 4, 5, 6, 7, which means 7 is going to be this underscore here. The first time it calls f, it is going to increment, it will increment variable I to 7, from 7 to 8. But it will return the value before the increment. In other words, it will print a 7 first. And then it's going to print 8, and then it will print 9. So the correct ordering here is 7, 8, and 9. And it will, but this question has two parts, okay? Because it has two parts, I want you to tell me when I is getting updated, and when I is updated, what is the value that I use to update I. So this part is going to be I goes from 7 to 8, I goes from 8 to 9. It is incremented twice. Is that okay? Now if you include the initialization, which you should, so it goes like 7, 8, 9. Those will be the updates of I. The actual output of the program is also going to be 7, 8, 9. Is that okay?
Yeah.
Okay, this one, how will you grade it?
I am going to grade it based on, okay, how many updates of I do we have here? There should be 3.
Okay, well that was easy, but I mean, I just got the last number wrong because I thought I did something funky at the end.
You mean this one here? You mean when
The
it
last
prints?
invocation of I, like I put like mine's like a 9 or something, so I put like 9, 10, 9 or something like that.
It should be 9, 10, and 11.
Yeah. No, I realized
So you
that.
get most of the points, but you miss one because the last one is wrong.
Yeah, okay.
Yep.
So for 8, the update is 8. I'm sorry, 7. I equals the update of I is 7 because I is assigned to 7, right?
That's the first update.
And that's not inside the function,
That's not inside the function.
right? So and then
But
it'll-
it is inside function main, but
Yeah,
not
yeah.
inside the
Yeah.
function f.
And then it goes to 8 because it's incremented within the function, and then it's updated to 9, and then that was just printing I, so that's not an update of I, so that stops the update. And then the actual output of the program is 8, 9.
What
To
is the
8, 9,
initial
9?
value?
No, for the output of the program.
What is the initial value? What is your last
It's 7.
digit? 7? The output should be 7, 8, 9.
How is the output? How is the printf, the very first one? How is that 7?
Because
That's
it
what I don't
returns the
understand.
value of the variable before the increment. Because I capture the value before I do something to whatever px points to. See this r here
So
is
that's
what
a
I'm
function.
returning.
That's a function of printf, that it's going to
That
print.
is that's function f, which I use to supply a value for printf to print.
I don't understand how printf is printing 7 before it's updated in the function. I thought a return r is the updated number because
What
it
am I
has to
returning?
return
What
the
is
function.
r?
The increment of
No.
that.
Because r gets the value before the increment.
Oh. Oops.
Okay.
Well,
Clears it up.
but it's not returning it until it's changed it.
Yeah, but what does that have anything to do with it?
Well,
This is-
because it's got the return value is what's printed.
No, but r is captured before whatever at px is updated.
Yeah, but it's not until it's returned that it's going to print.
PX doesn't update. I might be able to help on this one.
Yeah, go ahead.
Because when R is assigned to PX,
Uh-huh.
it's essentially like, say PX was 5,
Uh-huh.
you'd say R is equal to 5,
Yeah.
and that's its own thing. It's not saying R is equal to X. It's equal to a set value. So when that variable changes, R is staying the same because it was set like R equals 5, not R equals X. You're looking at it as like a math variable, but it's not. It's a constant. It won't change.
So when it's returning R,
It's returning whatever r has at that point, but r got its value before the increment.
oh yeah, now I get it. Yeah.
Yep. If you trace it, it would be kind of clear if you use the method that I talked about in class to trace this, because px will basically say c column blah blah blah. Okay, so you capture the
I knew
value.
it couldn't be that easy. I knew it couldn't just be adding one. I knew I was missing something.
Okay, question number 4. Question number 4 is a little long. Okay, we assume when we run this program, we redirect a text file as standard input file that has a full student ID with a line feed character at the end. So basically, it's the same thing as id.txt. In the following space, indicate a sequence of local variable x of main getting updated in the process. Note that you have to document all updates to the value of this variable, in regardless of whether it is updated directly or not. Okay, so it doesn't have to be directly updating x, it can be just updating the address of x or updating the content at the address of x, which means it's in function f. All right, so with this one, let's figure out what f is really doing. So when you look at function f, okay, the first thing it does is it is trying to scan f. It's reading a character and then it stores the return value of scanf into R, just so that we can do some comparison with R later on. What can possibly be the value of R in this case? It's attempting to read a single character.
It's going to be the first digit of your student ID.
Right, but what are the possible values of R?
1,
It
0,
can be
9.
1 if there's something to read. It cannot be 0. It cannot be 0 because you're attempting to read a single character. There's no interpretation. You cannot fail to interpret a character. So it cannot be 0. It can also be what? At the end of the file? -1, okay? So once I capture the value of R, then I have, if R is less than 0, which means we're at end of file, then whatever px points to becomes a 0, okay? And otherwise, when I did read a character, I would do the following. What is 10? Why do I compare CH to 10? The ASCII code, and 10 is the ASCII code of the line feed character. So if I see the line feed character, I would also initialize whatever px points to 0. And by the way, what is px pointing to? The only thing that I can pass to it is the address of x, right? So it's basically updating variable x in main. Okay. What about the else case here? This is a recursive call. But in the recursive call, what am I passing to the next invocation? Px all by itself. In other words, I'm passing the address of local variable x of main along to all the invocations recursively. Is that okay?
So this
Because it's recursive, so we'll end up with multiple invocations of f, but with each invocation of f, parameter px will still be the address of
The original pointer.
Variable x, you're saying?
it will still be a pointer or the address of local variable x of main.
Okay.
Yep.
Would it make a difference if on the recursion you put a star there?
No, you
Master?
cannot. You cannot put a star here. If you put a star here, it becomes the dereferenced px. When you dereference a pointer to an integer, what do you get?
Is that because you pointed to a pointer?
Wait. Okay, answer that question first.
Okay, what?
When you dereference a pointer to an integer, what do you get? And that value will be of what type? Integer, exactly. Can you pass an integer when an address of an integer is expected? Nope. So you cannot put an asterisk where I have highlighted here. Yep.
Is the asterisk, if an asterisk there, is it creating dereference because you're pointing to a pointer?
No, because asterisk means dereferencing.
I thought asterisk means pointer.
No.
Isn't that an asterisk?
Yes, it means px points to an integer.
It's different when you call or declare a pointer.
No, it's really the same thing, because what this is saying is px itself is not an integer, but when you dereference px, it is an integer. That's why the notation is saying int asterisk px is declaring the px is a pointer,
Okay,
because
so
it
without
says
the int.
say
So without the int, then it's a dereferencer. But if it's without having int there, it's a dereference because it's just point px, right? You need an int there.
when you're declaring a parameter, you have to indicate a type. Okay, so you have to say if I dereference px, I get an integer. That's how you declare the type of a parameter.
So that's a dereferencer, not a pointer.
This is not an operation. We are not dereferencing. We are not dereferencing anything here. We are basically saying what is parameter px. Yes.
So this program will almost like what you call your student number to just change it, right?
Say again.
This program, what it does is student number to almost like flip it, starting from.
Yes, this will actually flip all the digits. If your input is 1, 2, 3, 4, 5, 6, 7, it will come back as 7, 6, 5, 4, 3, 2, 1. It's a little tricky.
I don't know. I made somewhere else. And I think my numbers were almost like increasing, but I think the other numbers were off.
Yep, but all the updates, basically what I'll be looking at is the last update, or the first update, I should say. The first update is actually putting a 0 into X of main, and then it will be the last digit. Then you'll be multiplying the last digit by 10, and then plus the second last digit, and so on. So if I see the pattern like 2 or 3 times consistently, I would say, okay, this person has a general understanding of how this algorithm operates. So even if you cannot finish the whole thing, of all 7 steps, you'll still get a significant portion of the partial credit. On the other hand, if there's only one invocation and go like, okay, X is going to be 0, well, that's not going to be a whole lot of points, because the whole thing about recursion is missing. I do not see any evidence of any type of recursive behavior. Yep.
Mine's actually for questions 5 and 1,
Mm-hmm.
where the modulus operator was involved. I just blanked on how that works when you divide a smaller number by a larger number. But so I put it as 0, which is completely wrong. But I tested it, and if it was 0, I got all the right stuff when I tracked it.
So you got the wrong you misunderstood one particular case of the modulus operator. Yep.
Like, if my student ID had a number which made the modulus operator 0, I would have been completely correct. Does that get partial credit? Because I traced it correctly and did all that right, just with the wrong value.
I will be looking at, okay, if you consistently do that, yes, I'll give you partial credit for handling the recursive part right and for handling the rest of the program right.
Okay.
So, but it has to be consistent.
Yeah,
In other words, it cannot be like, only at this occasion I, apply the operator incorrectly.
Oh no, it was 1 and 5 were the ones
Okay.
with the modulus. Both times -1 divided by a larger number.
Okay.
So I just did 0.
Okay.
Yeah.
So when I grade it, I will kind of have to keep that in mind, because I think it's not going to be obvious. It's not going to stare me in the face and go like, oh, Kodiak misunderstood the modulus operator.
Yeah. Yeah, I just wanted to ask.
Only for that one special case.
Just wanted to ask now.
Okay. All right. This is the last one, which also has a modulus operator. And for those of you who read the original questions, you might remember this one as the original question too, except in the original test, this is in the form of an array using the value of a previous element as a part of the equation. And in this case, I do not use that. Okay? But it is still kind of asking you the same kind of question. So right here we have, the integers, being initialized. And, remember what const is? I kind of briefly talked about const. It is also in my notes here. In my notes, const means, these variables, so-called variables, are not real variables. They do not change. They cannot change. So once a size has a value of 5, that cannot change. Once prime has a value of 7, that cannot change. Well, that should not bother you much, because do I have anything here that can update a size or prime? No. So, whether I use const or not really does not matter, but it really is appropriate to use const in this case. So what this program is doing is it's just reading in your student ID 1 digit at a time. There are 2 tricks to this one. The first trick is, even though I say that there will be 7 lines in total, which means there's only 1 digit per line, okay? If you look at the loop, how many times is it going through the loop? It's only going through 4 times.
Yeah.
4 times. Because I start I with a value of 1, not 0. So it's only going through the loop 4 times. And then in addition to the loop, we have 1 additional scanf outside of the loop. So how many digits am I actually going to read? Only 5 digits.
5?
Only 5, because we got 1 here, and then we have 4 here. But how many digits is it going to print? It has. It only prints 4 digits, because this one is not printed. So it will only go through the printf statement 4 times, because there are only 4 iterations in the loop. Because I starts with a value of 1, as long as I is less than 5, we stay in the loop. So you count 1, 2, 3, 4. By the time it gets to 5, I get out of the loop. So we only go through the loop 4 times. Okay? Now if you go through 7 times, it's not the end of the world. It's just that you miss those points that I assign to, okay, can this person correctly determine when to exit the loop? Okay, because it's okay to miss one little thing like that. It's not going to be the end of the world, but there will be points assigned to that. Yep.
Is it bad syntax to initialize the value of a variable inside of a loop like that?
You mean here?
Yeah, it just looks bad. I don't know. It disturbs me.
Well, okay. If I don't do this, where do I do it?
You can do it
Before the loop?
Yeah.
Then what is the whole point of using a for loop? Okay, do you guys remember, every for loop can be converted into a while loop, right? Because you have the initialization, you have the condition, and then you have the post operation. Those are the 3 parts inside the parentheses of a for loop. Okay, why do we need an initialization portion? Because we want to concentrate, put all the initializations related to the loop at one single place. And that's where it is. That's why we have the highlighted code here. It is emphasizing and saying, oh, we only do these things to initialize stuff that is important to the loop.
Yeah. I don't know. It's just like the wording, and my brain just kind of wants to like reinitialize it, like whenever I see it inside a loop.
Yep, you have to train yourself to think more like the computer, and more specifically the compiler. That's what development is partially about, is to think like the computer. Because you can say that, I'm not going to use a for loop because I don't like this kind of statements. Remember what I said about your first job?
Oh, yeah.
You're not going to be writing code, you'll be reading the code of somebody else.
So.
Exactly. There's no choice. You don't get a choice of how other people write their code, but it will be your first job, which is to read and fix the code of somebody else who wrote the code like 20 years ago. And they may have go-tos, they may have all kinds of bad programming practice, and you have to dig through all that stuff to find out why the program is not working. Okay, so what is this program really doing? Well, the first part is kind of easy. I'm reading an integer into X. What integer am I reading in? The whole student ID or what?
The whole student.
No, only one digit at a time. Why is it only one digit at a time? What about the input that makes it one digit at a time?
Because there's 1% D.
One digit per line. And that makes all the digits separate. Okay? Okay. So it will read the first digit first, okay? The leftmost digit. Not do a whole lot about X at this point, okay? Except for this, okay? It will do a mod equal to. What is a mod equal to? What does it do?
Mod assignment operator.
Yep.
Makes
So in this,
whatever X will equal whatever whatever the thing that you're scanning, and then you divide it by 5, and then it equals whatever the remainder is.
okay,
X
so
equals whatever the remainder is.
so this basically is the same thing as X equals X mod 5, because A size is 5.
Yeah.
So that means if this digit is a 7, what would X become?
What digit is
2.
2, very good. So we kind of know what this is doing. So for this loop here, it's basically doing the same thing, except it's reading it into Y, which is local to the loop itself. Once it gets Y, what is it doing? It's saying, okay, this new digit plus whatever digit was before, and we'll add prime, and then this entire sum will do another mod with A size. And then we print it out, and then we'll go back and do the same thing over and over again. Well, 4 times, not. So it's really just doing the calculation. But your output, what is the range of values of this output of this printf line?
The range of output?
Yeah, what kind of value do you think this printf can print? From what value to what value?
Value of
From 0 to 4. Very good, because anything mod 5 can only be up to 4.
Yeah.
Yep, very good. So in this case, if I have 1, 2, 3, 4, 5 as the student ID, let's try to figure out by hand what is the actual output of this program. Okay,
Use
so
my student ID.
huh?
Use my student ID.
Let's just use this one. Okay, so initially x equals 1, okay, because 1 mod 5 is also 1. So in the loop, it's going to read the 2. So now we have 2 plus 1 plus prime, which is 7. The whole thing mod 5. And that's going to be, let's see, that's 10 mod 5. 10 mod 5 is an easy one. What is it?
0.
10 mod 5 is a 0 because it's divisible. So y becomes 0 at this point. The next digit that we are reading in is going to be a 3. So y equals to 3 plus 1 because x does not change, plus 7 mod 5. And that's just going to be, whoops, that's just going to be 1 because it's 11 mod 5. The next one is going to be 4 plus 1 plus 7. Whoops, I get it back. Take it back. Nope, that is correct. Yep, that is correct. So 4 plus 1 plus 7 is 12. 12 mod 5 is 2. And then the last one is y equals to the 5 plus 1 plus 7 mod 5 is 13 mod 5, and that is just 3. So the output of this program is 0, 1, 2, and 3. Those 4 lines should be the output.
Put mod 6.
Hmm? Oh, mistype. There we go. So that's going to be the output of the program, is the values 0, 1, 2, and 3. Okay, so I think there are only 5 questions.
Yeah.
Yep. Okay. Any questions about the test questions?
About how long will it take?
Oh, this is gonna take a while. Yeah. This is gonna take a while.
I'm just curious.
Can you post the questions onto Moodle just so we can rerun them again?
Yeah, sure. I haven't done that, huh?
No.
Okay.
Under what title would it be?
I can do it right now. Just hold on a second. Let me do this. Okay, so I have this. Go back to Moodle. Okay, so I'll post it under the topic of arrays, even though it doesn't really have anything to do with that. But that's where all the questions will be graded to. So I'll post it over here as a file. I'll do it in a slightly different way. I can go to the news forum and just post a news forum and make it an attachment. There we go. Exam 2. This is the question file. Just attach it here. And you should get it in 2 minutes or so. All right. Any other questions related to the exam? Okay. So we are moving forward. Okay. After Thanksgiving, we only get about 2 weeks left. And in those 2 weeks, we have to talk about some kind of really important topics in C and C++. So I want to point out to you guys, what you should read before Monday, just so that we will be ready to finish up this semester and get you guys ready for the next class. Okay, because the most important part is, am I going to prepare you guys for the next class? So I want to finish up arrays as soon as we come back on Monday, after the Sunday, after this weekend. and then we'll be moving on to structures. We have pretty much talked about all the stuff that is important about arrays. We haven't talked about C strings, but a C string is nothing more than an array of characters. Okay, so it is still an array, it's just an array of characters. And then we'll move on to structures. And you really want to kind of go through all my notes here, because there's a reason why I wrote these notes and put it onto Moodle. It's for you guys to read so that you can read ahead of me, so by the time I give you examples in class, you can ask questions about the examples but not so much about the concept itself. Structures I definitely have to go through entirely, so all of these things I have to go through. Program development is something for you to read, but there's really not a whole lot for me to demonstrate in class. So this entire topic about development, okay, program development, is just something for you guys to read, but not so much that I have to do something in class to demonstrate. There won't be any homework assignment related to just these particular topics. And then the next one is modular programming using top-down design. You know, that is already covered in some other places, so that's why it does not have its own topics. Advanced file input-output, I think we won't have enough time to deal with that. And you know, the kind of more important stuff would be object-oriented programming. So after arrays and structures, we'll try to get to objects and classes, because objects and classes, or object-oriented programming altogether, is closely related to structures in C++. So that's why those topics kind of align, and you know, they're really important for me to go over those things. And then there'll be the final exam. Okay, so does everybody know what is your current reading assignment? Everything in arrays, and also everything in structures. Okay, and just kind of read it the same way it is ordered here, because you know, this particular ordering is done just so that you know, the topics follow each other. Okay. Any questions? There's no homework assignment at this point. Okay, so there's nothing due on Monday, but on Monday I will give you a homework assignment that is related to arrays. Okay, so you definitely want to make sure that you refresh your memory about arrays, because we talked about that about a week or more than a week ago. So you might want to dig up the YouTube videos from, I think, the 16th or before the 16th, okay, and watch that first, just to refresh your memory of what we have talked about so far, and then finish up all of these topics. And if you have time, move on to structures, because that's also going to be a big topic. All right. Any other questions? You guys have any questions? Yeah. Okay. Well, they got questions, just not for me. All right. Well, you guys have a nice Thanksgiving. And I'll see you guys on Monday. Hopefully you guys won't be so stuffed that you cannot come back on Monday. I cannot even move.
I think you left this.
Oh, thank you.
No problem.